So go ahead and start. Here we go back into some examples with our graphing. And first of all, we want to look at this one right here. We want to say, what is this function? If you see something that is starting at 0, you're going to think, well, maybe this is a what kind of function? A sine function. You say, maybe this is a sine function. And then you follow the function and you go, wow, at 180 it's 0 again. And that's what the sine function does. And then you follow it some more and you go, well, at 360 it's 0 again. This is certainly looking like a sine function, right? So then you notice that it's going up to 6 and down to -6. So you said, well, that's different because normally the sign goes up to 1 and down to -1. So you can say, okay, this one must be y is equal to 6 sine of theta. Okay? And that's exactly what it's equal to. All that changed was the amplitude of the function. And the amplitude is this number right here in front of your function that magnifies or makes this go to 6 instead of 1. So it's basically 6 times whatever that output would be. And so it makes it go up to 6 and down to -6. So let's look at this one over here. And let's start by examining it. So remember, it's just like comparing those real dollar bills with a counterfeit dollar bill. You said, okay, what does this look like here? We're going up to 3 and down to -3, so that's going to be changing. So we know we're going to have y is 3 something. We're going to go, what is this function looking like? I don't have any function that goes down to -1. I have a function that goes up to 1. What's the function that starts at 1? It's the cosine, right? Okay, so maybe this could be a negative cosine function, because what does a negative parabola, what is a negative x squared? Y is negative x squared does what? Flips down, doesn't it? It becomes a downward facing parabola. The same thing could be true here. If this was a cosine function flipped over, would that work? Okay, the cosine is high at 1, this function, at 0, this function is low at 0. The cosine is low halfway through. Now, look at this. Has this one been, we've got it going up here, it's hitting a high spot, a low spot, and then it's coming back to the center again. Okay, so on this one, what has changed? If we were thinking about the cosine function, upside down, would that work? Okay, that's right in between, so that's not labeled, but that would be what? That would be pi, wouldn't it? Halfway in between there would be pi, and then it's low again at 2 pi. Does that look like an upside down cosine? Okay, a cosine would be high at 0 and 2 pi, and it would be low at pi, but this one is totally flipped over, isn't it? So just like a parabola will flip over when we put a negative in front, this is a cosine flipped over. So we're just going to put a negative in front of the 3, cosine theta, and that should be correct, and it is correct. They're calling it x here instead of theta. The reason they're calling it x is because they're using radians, and usually when they use radians, they will call this an x.
Do we have to do that?
Okay, you should. That seems to be the pattern in the book, so go ahead and use those. Call it an x. I don't generally ding you for that, but that's why they switch back and forth. Usually when they're using degrees, they use a theta, and when they're using radians, they're going to use an x. But you will always see in your books, if you will notice here, look at the 43.1. Everybody look at 43.1 in your book. Notice that when they have this grid here, they have all the degrees, and out here showing you what the axis is, they have a little bitty theta, okay? And then down here on this other example, out here when they have the radians, they have a little x on the axis. So when they're putting a little x on the axis, they want you to use x. When they're putting a little theta on the axis, they want you to use theta. I neglected to put anything on the axis, so you wouldn't know what we're using it, okay? All right, go ahead and cut that, Duncan.